Hello and welcome to part 3 of Making the Watch, where we have been following the journey of the Nardi HMS C20. We're still in the CAD environment, but we're nearly done with that. What I'm probably going to do with this part is continue to use the CAD, but to talk about every detail of the watch. I started to talk about spec in the last video, but I thought it'd be a better idea just to have a whole video dedicated to every component, so I can talk about how it's been made, and you can get a proper feel for how we want to put the thing together. We're getting very close to being near the end of this screencast format, and I know it's a bit of a pain. You guys want to start talking to real people. So once we've been through all of the different components in this video, I'm then going to talk about the methodology which we use for sending off this content so it can be turned into physical material for prototyping. And then we'll start talking to real human beings. So thanks for bearing with me. I know it's a little bit robotic, just watching a screen and listening to somebody drone on over the top of it. Yeah, but like I said, we touched on components in the last video, but I thought it'd be better to dedicate a whole screencast which talks about the processes of each component rather than from an engineering mechanical point of view. So more of a feature set, if you like. So we've got the HMS C20 in front of us. I've imported all components, even things that we will be outsourcing, so we can talk about it. And I'll include the Sapphire, even though I touched on it in the last video. It just seems more coherent to have everything in the same place. So I will start removing everything and bringing them back in one at a time so I can talk about each individual piece. So we'll start with the glass. As I mentioned last time, it's double dome sapphire crystal. As you'll notice as well, there is a beveled edge on the glass, and that's a bit of foresight with regards to the assembly process. When you're squeezing glass into the case with some pretty tight gaskets, it makes that process a little bit easier and you don't endanger the glass quite as much. Costs a little bit more, but I think we'll probably save on broken sapphires by using this method. And as mentioned in the spec, there'll be a single-sided AR coating, which will be the underside, and it's likely that that will have a blue tint to it, which is pretty common to see in dive spec watches. Nothing else to report on the glass. So moving top down, I think the next thing we would see would be the bezel insert. So if I just make that visible, and I will highlight the print as well because we'll need to talk about that. So the bezel insert will be ceramic, and we're outsourcing this, not abroad, but to a local jeweler who makes tungsten carbide and ceramic rings using sintering process. And they've got some great tech over at their lab, which we can't wait to get our hands on. To give you an idea what we're aiming for as far as quality, if you have a look at the Bremont Supermarine, another British company, somebody that we definitely aspire to. We're a long way off being where they are right now, but they're definitely a source of inspiration for us, with them being Brits as well. If you look at their Supermarine, you'll see that they have a very linear matte bezel insert, which is exquisite, really. So in order to achieve that, we're going to experiment with bead blasting, brushing, combinations of both, and basically do what is necessary to get that level of finish on the bezel insert. I mentioned in the last video, I'm totally fine with highly reflective polished ceramics. I think for this piece though, the matte thing is a little bit more classy. With regards to the marker printing, well, we're using bicolor pad printing. Pad printing is a technique which is really common for any kind of precision printing where the target is either very small, and therefore the print needs to be precise, or it has unusual surfaces, as in they're either concave or convex. Pad printing looks a little bit like this, so this is the process we'll be using. It's very common in the watch industry for dials and bezel inserts and other things that require very small, accurate printing jobs. We're undecided whether we're going to outsource this process. The machines themselves are not extremely expensive to purchase, and obviously if we can get our hands on one, it will future-proof us and make our business model a little bit more sustainable. So moving on from the insert, we're over to the bezel, which a lot of people agree is the pièce de résistance for this piece. If I go in closely, You'll see why we had such a debate on whether to use laser CNC or fine tool tungsten CNCs. It's a real precise job. Once we're funded, we're obviously going to have the scope to experiment a little bit, and we're going to stick with whichever's best. Cost won't be the issue. This is probably the most important part of the watch. I'm just going to remove the insert so we can see exactly what's going on here. So just to go over a few other of the sumptuous details of this marvel of engineering, what we have on the top lip is a slightly raised surface, which will help us with the ion plating process. Having a slightly raised surface there means that the plating will take a little better. You'll see that there's a recess on the inside, and I don't want to go too much into engineering necessity. That's not really what this video is about, but just so you know, that is for the ring retainer, which will help fix it to the case. Moving underneath, you'll see that this is a pretty solid structure, and quite weighty as well, to be fair. All these little recesses are for the click bearing, where it pops up to make the click and fix it into place when you turn the bezel. You'll notice that one side is ramped and one is flat. That is so you can move the bezel in one direction and not the other. So a little bit of geekery there for you if you're wondering how spring ball ratchets work. So next up, the case. The case. So this is going to be more about the features and the processes. I've already touched on the fact that we have the proprietary rehaut, which is going to be brushed, and in later variants we may even apply PVD coating where there's a necessity for a bit more stealth. The rehaut is drilled so we can fit our fancy quarter markers in, which obviously go a long way to making this watch quite distinctive. Are there any other features that I can talk about? We have the blades or haunches down the side, and you'll see that there's quite a complex cut at the join because the other haunches that are facing the lugs are slightly curved, so we got this really unique shape here which we're really pleased with. We could have just had a very angular edge, but having this slight curve just gives the case that bit of extra something. You can tell this is unscripted. For that, I apologise. But I think something else which might be worth pointing out is you'll see how the lugs kind of intersect the body underneath, so they don't just protrude from the face. That was purely an aesthetic thing. Because we have this dip curve in the top of the lug, just having it protrude from that face made the lugs a little bit thin. So in order to offer a little bit of substance to that, they go beyond the edge and they intersect the underside of the body, so you've got some real heft to it. Nobody really wants a tool watch that's got spindly parts, so it was always our core objective to try and make every bit as chunky as possible, for want of a better word. With regards to this process, because these videos are all about making the prototype, I think one thing that I will mention, as it's a slight caveat, the screw thread for the case back is quite large. So if you look at that, I mean, this will be different. So if you're looking at this wondering why there's a huge lip on that screw thread, when you're making prototypes, whether you're sending off for CNC or whether you're having polyjet resins, threads are an issue, okay? So in order for the thing to fit together, you want to be keeping them as simple as possible. For a production piece, you would need the 0.5mm pitch Swiss ISO micro thread. There is a specific thread tool for watches, which we will of course be using. But if you're sending something off to get 3D printed, or you're going to have somebody you've never met before CNC it for you, it can get expensive. So we made this thread really simple. Even if you do send this off for metal prototyping, you're going to end up talking to the factory, because you can't just spec a thread in a CAD drawing and expect it to come back working. So there's always going to need to be a conversation there. So for the point of creating this prototype, we want to keep it simple, stupid, so the thing goes together just fine. Which brings me on to the next thing. Where threads are concerned, they're the biggest challenge for any micro, especially if you're guaranteeing waterproofing. So our case barrels are all going to be bought in. They will already have the Swiss ISO screw threads and corresponding crowns, which will have the right gaskets in, and are already guaranteed to 200 meters. So let's talk about the dial. This we will be outsourcing. We've thoroughly vetted our supplier and we are confident that we can trust them to create a high quality piece. The reason it's being outsourced abroad is that it requires injection molding, and tooling costs for injection molding, especially hard plastics, are extremely high, as you will see when we get to the prototyping phase in the next video. It's a fairly complex dial in the sense that we will be using pegged indices rather than just bonded. And just as a matter of interest, the extrusions that you can see here are what secure the dial and stop it from rotating freely once it's inside the case. The indices themselves will be laser cut from steel, and the quarter markers will be flash plated in gold. And we're going to experiment with brushing that gold as well. That may be a detail too far, but we're going to try anyway, because it'd just be another level of complexity which adds to the mystique of the piece, if you like. You'll notice that the indices are all bucket types, and we're going to fill them up with loom. So the loom is nice and powerful. So whilst we're on the subject of loom, and a question that's been raised a few times, is about the colour on the minute hand. Is that the loom, we get asked. The loom is uniform across all components. So it's the same for the hands, the indices, and the bezel insert. The way we get this hand to be green, so it matches the watch's theme, for want of a better word, is to add a dye to the loom compound. And it's the kind of dye that you use to colour resin. So it has an index of refraction, so it's kind of see-through. So it doesn't kill the loom's brightness, but it will colour the clear areas of the compound. There's a slight loss in brightness. Not measured it, but I would estimate somewhere between maybe 10 and 15%. So the minute hand will be slightly less bright. So to answer the question in a nutshell, before I become a complete bore, the loom is the same across the board, but the minute hand has this dye applied to the compound, so it will appear that colour in daylight. Okay. As per usual, I realise I've been drivelling on for a while now, so I will wrap up with the final two components in one section, of which the first doesn't really need explaining in too much detail. So we'll deal with the movement holder and the case back. So standard movement holder, it'll be attached to the case with screws and clamps, and the movement will sit therein. It won't be being made out of the same reprocessed HY80 steel that the case will be. That would just take the cost too high. We'll probably use some unfinished stainless steel. It'll be precise, but I wouldn't expect it to be pretty. I think that's as fair as I can make that sentiment. The case back, standard screw down. We're going to use a wholly different supplier for the ornate case back, because we found a local supplier that has a very, very good engraving CNC, and basically they've agreed a good price with us, and their work is exceptional. So this part of the watch will be visiting more people than any others. There'll be a lot of work done on it. So I think, albeit vaguely in some areas, I've managed to cover every aspect of the watch. What I'm going to look at in the next video is sending these components, because these are manufacturing ready. All of these parts could go straight to an engineer or straight to a 3D printer. So in the next video, I will talk you through that process, and we will get the various elements bought and paid for, and we'll start working on some of the third-party elements and putting them together, and start being a little bit more craft orientated. So I think that should do for now. As usual, leave me a comment or a question, or if there's something I've been unclear about, because this is unscripted, obviously. Just fire your questions over to me and I will answer them. All right, well, I will see you in the next one. Goodbye.